So the next talk will be by Tomi Kauppinen. Yes. So Tomi is from the Department of Media at Aalto University School of Science. And Tomi, introduce yourself.
Yeah, of course. I will say. Typically it works. But this time it works. So where do I put this? Yeah.
I'm going to see your presentation.
Okay, yeah. It was a nice presentation, thanks. So let's start. Good afternoon, everybody. So I come from, actually it's Department of Media Technology, so it's not Department of Media, but anyway. Aalto is University School of Science. So my background is, I did a PhD in Aalto University like 4.5 years ago, but after that actually I've been a lot in Germany. So first in Münster, 2.5 years, and then in Bremen even 6 months this year as a professor in cognitive systems in there, and then back to Aalto University. So today I would like to share some of my experience about spatial data, and especially about the role of spatial data for connecting different scientific assets. So linked science, I call it. How many have heard about scientific assets? What are scientific assets? I mean, who can name one? Publications? Who knows publications, right? Okay, good. I mean, data, methods, tools, tutorials. I mean, do you think about all of these as something that you want to share, right? I mean, in linked science, what we want to do is to, first of all, of course, share all of these different assets, but then also to really represent the interconnections between them, right? If you think about it, I mean, everything is linked to everything, right? I mean, in the scientific world as well. Can we represent all of these linkages? And if we can, I think it's a big promise that, I mean, we can perhaps make use of all of this together. So if we describe about all of these assets, like where, when, why, what, who, then we might actually get the linkages for free. I mean, especially the question is if we can use somehow the where question, I mean the spatial question, to connect all of these different things. So let's zoom, for instance, to Münster. So this is the campus area. So we can zoom with this application to different campus buildings. And here we see the amount of publications by building. So rector can zoom in and zoom out and see that, well, nanotechnology, you are doing really well. What about the history department? Not that well. And, you know, kind of, I mean, these are just examples. It's like understand how the university works. And it's not just publications. I mean, we can also use amount of people. We can use the amount of funding, anything basically. And for this, we need links. So how many links we need? Can you guess how many links we need in order to make this kind of visualizations? Anu? Or somebody else? Who guesses? Do we need 100 links?
One link from the attribute data.
Well, yeah. Well, actually, we could. But first, we have to come up with that one link. I mean, first we need perhaps more links in order to come with that one link. Well, I mean, well, yeah. Actually, that's very good. So what you are telling about is the kind of amount of all links together. Yes, that's very good. But what I was searching for is like linkages between different kind of things. So first of all, we need a link between publication and the person, right? Person and the department, department and the building, building and the space, and perhaps even also publication and time, because I mean we want to restrict somehow the visualization, right? And then we can simply aggregate all of this information together and use pie charts and whatever to analyze them more properly, or use Google Earth to browse all of this information and make it really interactive where you can simply click any of the buildings and see everything what happens. So I mean, DFG, would you like to make use of this kind of tool for analyzing all of the results of the you don't want to use it? Okay, well, I don't know. I mean, if I would work for DFG, I would certainly like to use it. So the point is that data has a story to tell. I mean, so if you think about reuse, I mean, if we provide all of the different connections about everything, I mean, of course, it's kind of a vision, but I mean, we can really find out many stories from the data. I mean, not only the story that the original scientist had to tell, but also many other stories. For instance, if you look at the, let's look at another university. Aalto University has also started to publish open data, linked open data, which we initiated a few years ago. So there is a lot of data, like about courses, for instance. So I mean, somebody has collected all this information, I mean, at some point, and then thought that okay, it's useful to deliver to students information about courses. Thank you, but does this data have also some other stories to tell? Actually, it does, a lot of different stories. So what we can do, we can, for instance, take all of the people who have public profiles. It's in the same data set from the university. And then we can simply follow the different links between departments and people and department and school and so on. And make this kind of visualization where we can click on the whole university, and then we can see all the different schools and how many people are actually working in those schools. And then follow these links, like click one school, and then we see all the different departments of that school. Right. So if we provide these links, then we can make different kind of projections to the same data. Not the original projections, but new ones. So that is the promise. The big question is how can we really support this kind of storytelling? So what kind of technologies we need? Anu? Linked data. Anu was right. Anu, here. Thanks. Very good. So linked data. Why linked data is so good? Who knows linked data? Who has heard about? Christian? Yeah, okay, very good. 2 persons. How many? 3, 4. Okay. So what do you know about it? Why is it so good? What is the nice thing with it? Who is the first one? Anybody?
It has a semantics included?
Well, yeah, mostly. I mean, not even always, but yeah, that's a good point. Yeah?
It gives you a new perspective on data.
Yeah, well, yeah, that as well, because you get the links. But the most crucial thing with linked data. Think about how we share it. How do we access it? I mean, that is the. I think that is the most crucial part, because it's available. I mean, linked open data. If you create it, it's openly available by definition. So it means that that we can actually access the linked data access point called Spatial endpoint, and then we simply get all of the data and we can visualize what is there, right? So we can see, for instance, if we access the University of Münster database, we can clearly see what kind of things they are. I mean, they seem to have a lot of information about lecture halls, doors, meeting rooms. You see, I mean, it's like if we plan to do some research on this data, we can simply get very fast a overview of all the data that they have published, and then we can start comparing all of this data, perhaps even with some other universities, right? So we just take data from one university and then check Aalto University and perhaps Bristol, I think, was the third one here, and then we see what kind of things we can actually compare from all of those 3 universities. What are the common classes or common things? And it seems to be articles, persons, reports, books, and documents, and thesis. The point is here that if we do this kind of analysis, now we can see that we can only compare these handful of things about all of these universities together, right? So should we do something? I mean, should we publish even more linked data? You see, I mean, because I mean, for instance, University of Münster has published also information about what was meeting rooms and so on. So if you want to compare two different universities, how they use their meeting rooms, we cannot do it, right? So it makes it very visible, like what we can actually do with the research data or university data or whatever. So I think, I mean, this is just a proposal. Perhaps DFG could look at these things and then, I mean, simply require people to publish the research data. And with these kind of tools, we can actually see, I mean, really transparently what they have published and when and where, right? So it's a lot of different kinds of links together, publications, persons, organizations, buildings, research, anything. This is another example. Let's look at live. So this one. So with this kind of tool, a rector or actually anybody in the university can go to different buildings and see how many lectures there are over time in one building. And does it also have some story to tell? I mean, what kind of story? How can we use this kind of tool? Who is the first one again? It shows the amount of lectures over time by building. So
optimizing.
Exactly. How expensive are university spaces? They are really expensive, right? So, are we worried? I mean, yes, you see. I mean, they are kind of half empty here, right? I mean, I have showed this to management of Aalto University. They are really worried, and they told that nobody have ever before been able to tell this story. Well, why not? I mean, because the data was not published as linked data, first of all, and then also connected with other important things. Like also here, you need to connect the lecture to course to building, building to space, and so on, right? So, I mean, it's another example where actually it saves a lot of money to do linked science or to publish university data as linked data. So one interesting hypothesis is whether and what exactly is a good integrator of data. And hypothesis is that space and time are pretty good ones. I mean, Janovic has written about it as well. And there are quite a few questions related. Like first of all, we have to really think carefully, like how actually different things are related to space and time. Are there different ways they can be related to space and time? And also what kind of events can happen and where, what kind of links they really are, and how do we represent them? What we have done is, I mean, one of the examples is to take a lot of data about the Brazilian Amazon rainforest. Who knows Brazilian Amazon rainforest? Who knows rainforest? Okay, Amazon rainforest. Okay, Brazilian Amazon rainforest. That is the rainforest that is in Amazon and in Brazil, right? So we took a lot of data about it, like ecological, economical, and social data. And then what we can do with this kind of visualization is that we can zoom into all of this data and see, for instance, how much money they make in different places. And then compare to like how much meat they export to different countries, in order to understand like where they actually make money and where they make deforestation, and are they correlated and linked, and is, you know, why do they actually deforest? Because they want to have cattle there in order to export meat to China. That is this arrow here, right? So I mean, it's a lot of ways we can actually communicate about this data once it's there. And when it's there, then we can simply start making or creating stories about it. This calls for like really to support information usability. I mean, the promise is that that if we create representations of the linkages between very different kinds of things, and remember, like, how do we actually create the links via space or time or common classes or whatever, then we actually support information usability. But of course, there are the challenges like, I mean, what exactly should be defined and when, and also at which aggregation level you should work. For instance, about the Brazilian Amazon rainforest, we found out that if we link via municipalities all of the data, then we can actually create stories, because there is a lot of data about municipalities. But remote sensing is typically done in as grid cells. I mean, it's aggregated to 25 kilometer grid cells or something like that, right? Which doesn't help yet to create these interesting stories. But when we aggregate to municipality level, booms, then we get a lot of open data, and then there you go. You can start creating these stories. Good. For the last 5 minutes or so, I would like to have a discussion. I have a lot of other demonstrations as well. So these are the discussion points. How do you feel about it? What do you think? Yeah, well, you can read. I can also.
It's very positive.
Okay, thank you. Thank you. Yeah. So what we do, we have a community called linkedscience.org, where we organize. We organize workshops, but we also organize tutorials. We publish online tutorial materials where you can actually check how things are done. And then what I feel is really necessary is to have online tools where you can actually test yourself how to check, for instance, quality of certain. Thank you. Yeah, 5 minutes.
Do you want to comment? Did you ask for feedback?
Yes, sure.
Okay,
yes.
So I have a comment. I think this is really important work, and I come from the metadata end, but one of the key points, I think you made it, but it's worth restating, is that the linked data makes data and data about data machine processable.
Yes.
And there's a lot of work where people are repeating stuff over and over again daily. And people are cutting and pasting identifiers from one place to the next.
Yeah.
And typing terms over in vocabularies that can be shared. And so linked data or linked open data really can allow for greater machine intelligence and save the time for the human to do the things where humans really need to disambiguate. And so, I think this is really important.
Yes.
Nice to see this.
Yeah, very nice to hear that comment. Let me show you one thing. So we were talking about incentives earlier. I mean, there were a lot of questions. I mean, what are the incentives? Let me show you one very good incentive. I mean, at least I think about it. It's a good incentive. So why would a scientist share the data? Well, we don't know it, right? Well, what if they want to improve the data quality? Do they want to do it? I think they want to do it quite often. I mean, because they want to understand whether they're actually close to truth or not. They want to have good data quality. So we have built this tool, and this is exactly to check the data quality. So how well the data is described by different vocabularies. So we just type in a Spatial endpoint, right, like this, and then we click, and then it analyzes. And but luckily I have already done the analysis. So so these are all the different data sets in linkedscience.org that we have analyzed with vocab.dat. So how does it work? It creates automatically this kind of documentation. So from the data, automatically, everything is done automatically. So first of all, this saves a lot of time from the researcher. They don't have to do it themselves. It creates a document about the vocabularies in use to describe the data, classes in use, properties in use, dataset linking, and assessment. Do we get 100%? It shows how it is calculated, and well, for this particular dataset we get 100% quality. So So the idea is that, yeah, vocabulary score 100%. Right. But as you can see in this list of different versions of the analysis, I mean, first our data set was not 100% of quality, right? So we first, I think we did one of the first ones was this one. And that's already when we had a journal paper about this. Then we thought that, okay, perhaps we'll test our own tool, whether it's actually following the... so the vocabulary score was 0.4. I mean, then we were a bit worried. I mean, then we tested it, and I can show you how long did it take. So it took like something like 2 weeks to come up with the from 0.4% to 100%. So this means like if we look at the classes in use, so can we find out online vocabularies that are actually defining these terms? So so this is very important, because if we cannot find, then it's, I mean, we cannot reuse the terms. Yeah, this was kind of long.
I also have a comment to the university example.
Yeah.
When you showed of Münster the open data, I think that's brilliant. But at the same time, for example, in our university, we also have now this monitoring of how the buildings are used and so forth.
Yeah.
And there's a huge, let's say, reluctance to join this activity.
Yeah.
So if you so clearly show what you can do with the data, this will, at my opinion, maybe will not produce many universities to join, actually, because you can intercompare not only in Germany.
Yeah.
So for us as a researcher, we are already very open. Monitor, but for example, the administration, also in some universities, it's not so open and transparent as you said before.
Yeah.
I think that's quite a problem.
Yes, I agree. So I think for that we need to show with good use cases and applications that it actually makes a big difference in to be open. Because if we are open, we can create other stories, not just the story that we at first place wanted to tell, right? So we can actually save some resources. So for instance, in our university, they want to save a lot of money about, I mean, they want to put people to smaller spaces, right? And at the same time, you have big lecture rooms completely empty. I mean, it doesn't make any sense. So with this kind of visualizations, we also want to show that, I mean, you are saving from the wrong place. And also perhaps even we shouldn't build just, big lecture rooms and then separate spaces for people to work. I mean, should we somehow combine these kind of ideas? I don't know, but this
so
one.
What I mean is, this is exactly maybe addressing the question, how will we ask the scientists to provide data?
Yeah.
This somehow also makes this work transparent.
Yeah.
And maybe reproducible, which actually is science, and everyone who may be sitting in this room thinks this is a very good idea, as I also thought the approach is very good, but this also somehow addresses exactly the problem that as soon as you deliver your data, what you do and how you use the resources is very transparent, and this is the point where we usually do not get any data anymore.
I mean, I see the point, but I think we have to work on these incentives. I mean, if we give back, like, okay, if you share your data, then you can actually get the documentation of it for free, or for almost for free, right? So you can easily see, like, you can compare, let's look at this one. So the way we can compare, like, our data to other university data. So if I as a researcher publish data about some phenomenon, if I can easily compare that data with other researchers' data about the same thing, whether I'm on the same track or not, I think it's a big incentive. I mean, then we can actually ourselves also see, I mean, position ourselves. So, but yeah, I mean, this is my proposal for the incentives.
Thank you very much.
Thanks.
Are there any more questions to the talk? No? So then I would like to ask everyone to gather when we leave now for the coffee break and the next poster session at the stairs, and there we will have the group photo. Yeah, in the next one. Thank you.
Okay, thanks.
I can show you some linked data.
Huh?
I can show you some linked data.
Excellent, thank you, please.
Yes.
I will immediately use my tools to access it and analyze it. Okay, thank you.